All right, so what I was told to sort of talk about today was kind of talking about how to make a topography surface within Revit. And a lot of times, and this is good that we actually have this file, the AutoCAD Site for N DWG file that's part of your class. I guess it's on your Dropbox, so everyone has access to it. One thing that's key about working in topography and using topography drawings such as this, which would be kind of like a survey drawing, where it looks like somebody probably recreated this by tracing some kind of map file that had contours and then had that as an underlay in DWG format and kind of traced it, because it looks like each of the contours are their own individual layer. So like this one happens to be 734, which I would assume is like the contour line 734. The next one over, we're down to 733 and so on. So we got 1 foot contours that are shown on here. So the important thing about trying to bring this into Revit is that if I were to look at this DWG file, and I've got this kind of open in AutoCAD, and if I were to look at this in a elevation view, I should be able to have not a straight line. So basically what you see there is all the color lines that are up there on the screen, those are all those contour lines, and they're actually at the height of 734 in the z-axis, or 733 or so on. If you get a file where you turn to the elevation view, kind of like I just did in AutoCAD, and this is all one complete straight line, basically what we're about to do in Revit won't work. So what you'd have to do is go to each contour line and move it up to the correct elevation. So if it was all a straight line, it'd be all at 0 or at some kind of plane. And so if you had actual contours that were 734, 733, and so on, you'd actually have to physically move them in AutoCAD first up to those locations in the z-axis, and then we could bring it into Revit.
Is that regular AutoCAD?
This is regular AutoCAD. That's on the screen here. So, so anyway, we've got a file that looks like we can actually work with, so that's good news, since this is the first time I'm seeing it. Otherwise, we'd have probably some issues here. So all I'm going to do is I'm not going to really save anything in that. I'm just going to exit out. But if everyone has that file handy, we're going to need it when we open up our Revit. So if you can open up Revit, and we're going to go into the project environment, because that's where we can work with the mat or the topography tools. Get that up on the screen. So just go to architectural template, and then we'll kind of work on it from there. Now, two things that I like to do when working in topography in Revit is, number one, I like it to be its own separate file, and there's going to be a reason for that. Essentially, the site model is going to be something that you eventually link into your own model that you're working with. And why is that? Your building that you've been working with so far probably has a level 1 set to 0, right? You probably have then your floors after that, going up from the 0 plane. This site model, when we bring it in, it's going to be up at 734 feet or 735 feet, wherever those contours are. So what happens is you're going to have topography floating above your model, and then you're going to have to figure out how to kind of merge them together. It works a lot better if you can have it as a linked model, because then it can just come in as a big group, and then we can move it into place. And you have to determine what your finished floor elevation is going to be in order for this to work. But first, let's talk about how to actually use this file. So if you can open up Revit and get into an architectural template. And I'm also going to click on View and then also make a 3D view. So our default 3D view will be what we'll kind of work in. Now the topography tools are over here under Massing and Site. And so it looks like there's not a whole lot that's available, but there are once we get a topography surface in here. So there's basically topo surface as a option, and when you click on that, you'll see there are a couple different ways of making a topography surface. One is by placing a point. So I could actually place points if I were to go into, let's say, a site plan. And if I click on place point in my options bar, there's a little elevation that's set there. So as I place points, and this would be basically if you didn't have a file like we have, so our DWG file, let's say you didn't have it, and all you had was an image file to trace. you'd bring in your image file, and then you would say, okay, this contour that I'm tracing is at elevation 0, for instance, and you'd go around and start clicking points exactly, sort of following the contour. Then my next set of points, I would type in, will be at a 1 foot contour, and maybe those are up here. And as I do this, it starts generating my surface. So this is one way of making topography surface if you don't have any kind of DWG survey file. When you're done, you can just hit the checkbox, and we can look at this in 3D. And so essentially, it's making a surface that is going to follow those contours. Now, the topography surface is only going to be a flat plane. It's not going to be like in SketchUp where everyone makes their chipboard model where you extrude a thing up every 1 foot and then you box it off and make a base and do all of that type of stuff. Your topography in Revit is only going to be this surface. It's going to be flat. But when you start cutting sections, and if I in my floor plan views, your topography is probably going to be turned off. So in your visibility graphics, you want to, let's see, go under topography there and turn them on. But what I was going to get to here is visibility graphics, topography. Is that when I cut a section, let's say I was cutting a section through my building and so on, you will get the kind of classic hatch pattern that's associated with drafting ground is already going to be generated based on wherever the topography surface is, where you're cut, and so you'll see this cut line is pretty dark up there, and then you've got this topo surface or the kind of hatch pattern that's associated with the ground, and that's going to change based on what scale you're at. So if I'm at 1/8 inch, change that to 3/4, you can see how that gets that hatch pattern gets a lot more detailed, and that hatch pattern is basically goes down based on our topography settings. So if you go to massing and site, under model site, there's this little button here. It's like this kind of down arrow is pointing to the down right, and that's your site settings. When you click on that, this gives you how your topography is going to be kind of showcased, when it's in the model. One would be what do you want your contour line display to be at? Right now it's set at intervals of 10 feet. You could make that more detailed by saying I want to show every 1 foot or every 6 inches or however many contours you want to see when you look at it in plan view. The other part will be down here at the bottom, the section cut material. So this is how it's showing you that earth pattern. So section cut, you can actually change that if you want by clicking on this button. It'll take you to your materials, and you could change what type of hatch pattern you actually want to see when it's cut. But again, I also like to make this hatch pattern kind of a gray color instead of being black. This way we kind of get a nice look when we're printing it out eventually. The other part is the elevation of the pochette base is the next option there, and it's saying -10 feet. And what that means is it's going to show the topography when you cut a section. It's going to show that hatch pattern -10 feet from the lowest level. So lowest level here is level 1, which is 0. So if you wanted this to extend, let's say 100 feet for some reason, or 50, you can just change that to say -25 feet or whatever, and then you'll see that this hatch pattern now continues a lot further. So I can kind of expand that a little bit. It's kind of hard to see up there. So there you can see how it's now going another, it's going 25 feet instead of 10. So that's going to really help a lot of your section drawings and elevations. When you start cutting them through your topography surface, you're going to really have a ground plane that represents exactly where it should be relative to your topography, your contours, and then how it's attaching to the building. And we'll go over how to make the interface between the building happen a little bit better here in a minute. So that method that I just showed there, that's obviously if you just had an image to trace. Since we have a DWG file, we actually have a topography surface that can be generated really easy. So the other method here for making a topography surface is go back to topo surface, and we can actually use the create from import, and there's a little pull down menu for that, and there's two parts to it. There's select import instance, and there's specify points file. You're going to only worry about the select import instance because that's going to be if you have a DWG file or something that you can bring in. The points file, that's something that is coming out more, is becoming more and more popular nowadays with GPS systems. You can actually download, GPS coordinates from different websites, and it basically comes to you in like a CSV file, kind of an Excel spreadsheet that is plotting out the X, Y, and Z points. And so basically, if you had a file like that, you could say specify from this points file, and it'll actually generate the topo surface from all that GPS data. But for right now, we've got this one, the select import instance. I'm going to close out of this, hit that X box, and basically in order to use that option, we need to go to Insert and then Import DWG. So there should be Import CAD. You don't want to use the link CAD, you actually want to import it. So we're actually going to hit Import CAD, and then I'm going to browse to wherever that file is. So let's see where I ended up putting that. So here we go, we got the site for N, and there's a site for N copy. I assume those are the same thing. So I just use the site for N. And the other part is what I want to do is down at the bottom where it says positioning and it says auto center to center. I'm actually going to change that to origin to origin. This way it pops in exactly where it is, in the DWG file. And we'll say place at level 1, that's fine, and we'll keep all the other stuff there. And we'll just click open. It might take a minute for it to come in. You see the little green bar down here. And so there you go, you have the file that comes in, and I assume this is to the correct scale. But I probably shouldn't assume that. What is that? So one thing that you probably want to check is, looks like there's some floor plan information on here from something. So you would probably want to go back into the AutoCAD file and just verify that when I strike a dimension, and I'll do it from this line to here, that wherever you're striking a dimension, this happens to read 1 foot 2 and 9/64 of an inch. So I'm assuming this is probably scaled right if that was supposed to be a wall. But anyway, if it wasn't scaled correctly, what you could do is you just select this whole entire file, and you can hit scale, and you could do and it says it can't move a pinned element, so you want to unpin it. There's a little pin option up here. And you could actually hit scale and then either enter in the numerical scale, how far you have to go, 1.25 or 0.5 or whatever it is, or you could do a graphic scale like we've done with the images and so on in previous seminars. But for right now, I'm going to keep it. It looks good. And I'm going to look at this in 3D. So if I look at a elevation, so it looks like this contour DWG is actually, even though those contours read 734 and 733, they're actually not at that true height in the Z location based on that DWG file, and the reason for that is this came in right at 0. So somebody probably picked whatever their finished floor elevation was and did all those contours 1 foot up and negative 1 foot and so on. So it looks like we'll just have to work with that for now. So actually that might be all right. So now to use this topography surface generator that's part of Revit, the way this works is going into massing and site. If you hit topo surface and now click on create from import, I can hover over that DWG file and you can see how I can select it. So when I select it, it's going to bring up this dialog box. And this dialog box is saying, okay, from all of the different layers that are part of this DWG file, what do you want to use to create the topography surface? So the other important thing about your CAD file that you have is that your contours need to be separated from everything else from that file. So if somebody happened to put all the contours and all the building outline on one layer, then you're going to have a problem with generating a surface. It's going to generate something kind of funky. But it looks like on this file when I looked at it, I'm going to hit check none, But it looked like the names of the contours, so 706 through 738, look like those are all the contours. So I'm going to select all those and hit the checkbox to select all of those. You need to go to topography surface, so massing and site, topo surface, create from import, select import instance, and then you select that CAD file that's in the 3D view. That'll bring that up. And all I'm going to do here is hit check none. Then I'm going to scroll down to 706, and then scroll down further, hold in the shift key, select all the way down to 738, and then select all those check boxes. And if I look at the rest of the elements here, it looks like there's a topo surface that's already in there, probably generated from Rhino or some other program. I'm not going to select that because we're going to be making our own. And it looks like all the other layers don't have anything to do with topography. So once I select all that, I can click OK. And it'll take a minute to generate. But what it's going to do is basically place a point all along all of those topography contours. And so you end up here in a minute with a bunch of points, just like I was doing with the place point command, where I'm sitting there going place point by point by point. This basically just traced that whole entire file for you, and when you hit the checkbox and done, you're done generating a topography surface. So now I can actually delete this CAD file, and here's your topo. Or I could hit Control Z there so I can keep my topography in there, or my CAD file, because there's a couple things we can do with the CAD file if it's going to be easy to use. Let's see. So anyway, that's kind of the nice thing. It's a quick shortcut, as long as, again, those DWG files were set up correctly, and now you have your contour surface that you can bring into your model. Now I talked about linking that in. The fact that this already comes in at 0, you may be able to just use it as is without having to do a link. So you might disregard what I said earlier on the linking part. So what you could do now is if I wanted to move this up and down based on where my building is located, let's say you decide that your finished floor is supposed to be at 735 elevation or something like that. One thing that you can do is once you have your topography surface, let me go into a site plan. I'm going to turn on my shaded view. If you don't know, well, it's kind of dark. Let me turn on the hidden line. I'm going to hide this CAD file for a second. So let's say you're working with this file and you're not really sure what the elevation of this surface is along the whole entire topography, from one contour to the other. You can just go to annotate, and there's this little option here called spot elevation. And if you click on spot elevation, I can hover over a portion of the anywhere on the surface, and it will give you a readout of what that particular spot elevation is of that contour surface. And that's going to be relative to 0. So the fact that this came in at that 0 mark, you're going to have to kind of figure out relative to 0, whether you're up 2 feet or down 2 feet or so on. So if I go down here to, it looks like here we're sinking down into the ground, I should be able to do another spot elevation. You can see here that's negative 28 feet 4 inches down below there. So it must be some kind of big pit, or maybe there's water there or something, and that's the bottom of the lake.
Service anchor next to the CCB.
Is that what it is? Okay. Yeah, it looks like a little ramp going down. So anyway, that's how you can get your your different spot elevations. And what I would normally do with that information is, if I know that my finished floor, I want it to align with this portion of my topography model right here. So here it says 1 foot 9 inches, and that's where my finished floor, my first floor, is located. Then what I would do is go into an elevation view, click on all of this stuff. I'm going to hit filter. I just want my site for NDWG and my topography surface, and I would just move this down 1 foot 9 inches so that that section gets to 0, which would be 0 compared to your level 1. Does that make sense? So that's pretty much the best way to sort of work with it, but you have to decide where your finished floor elevation is going to be relative to the topography in order to make that happen. In the real world, and if this came in at that 733 elevation mark, I would have said, okay, my finished floor is really going to be at 733. Then I'd go into my elevation view and I'd actually move my contour model down 733 feet to get to 0. Does that make sense? All right, so once I have that, I'm going to Control Z that so I don't move it. Any questions so far about that? Seems pretty self-explanatory. Now, once you have this topography surface, we can do a couple things, such as start to divide it up into different parts so that you could delineate what's road versus what's dirt, what's grass, or other materials. And to do that, it's best to go into, let's say, a site plan. I'm going to turn back on that DWG file. And it looks like I've got at least some outlines relative to maybe some roads. Looks like at least I have these components. And if I don't know what layer something's on, with the DWG file, I can always select it, select the actual CAD file, and where it says query, I can click on that and then hover over different parts and pieces, and it'll actually tell me, what I'm looking at as far as what was part of the original CAD file. So it looks like I could probably use those outlines for a sort of a division there. So what you can do is under massing and site, we can create what's called either split surfaces or sub-regions. So a split surface is exactly kind of what it sounds like, and let me again hide this CAD file and we'll do an example. So a split surface would be, if I click on that, I can click on the surface I want to split, and then it's a matter of drawing a line through the surface, exactly how you want to split it or cut it. And I'm just doing this as a quick example. And when I hit the checkbox, it now splits this into 2 pieces. Now to make these roads and other things, I'm going to Control Z that. I don't really want to do the split surface. I'm going to use what's called a sub-region. And I'm also going to, again, turn on my CAD file so I can see what I'm working with. And if you create a sub-region, what that basically is you're creating basically a split area within the topography surface. So it needs to be some kind of enclosed area that you can make into a region. What that means is I can come around here with my pick lines command, and I should be able to pick kind of this, those are all individual lines there. I'm going to use a 3-point curve. So you kind of have to trace some of these parts. I'm not going to get too detailed. Let me just get a couple major lines here. I'll just pretend that this continues that way, and then we'll do a bottom. So let's say I've got that component there, and I'd probably go around and trace all the rest of these items, and I could probably, let me just do some basic shapes here just for an example. I'm going to click Edit Boundary, and I'm going to go back and finish this up. So obviously I'd be a little more detailed in my kind of tracing here, but you can see how I'd be boxing around all those parts, and what I'm doing here is I'm trying to isolate basically a region, and so what it's going to do is cut a region, a topography surface, out of each of these regions that I'm creating, and that will allow me to then specify specific materials to each of these regions. So I can hit the checkbox here, and just telling me about my spot elevation. Now when I look at this in 3D, kind of hide that file again. I can now select, let's say, this one portion of the topography surface. Looks like it's still selecting it all. That's strange. I can select all those individually, but when I try to do that one, it selects everything. So anyway, let's try something out here. I could change this to be a material. Let me make it probably asphalt, and I probably don't have that loaded in here. So again, just a little recap on working with materials. If I click on this little panel right here called Show and hide my other pane down here, I can get to other materials that come with Revit, and I could scroll down here and find the one called, I think it's probably under, I've got miscellaneous, let's see. So under miscellaneous, it looks like I can find one here called asphalt pavement. And all I have to do is double left click on that, and that'll add it into my project. And then I can use that to select. So there you go. You can see there where it made now all of those sub-regions that I just selected there into the asphalt color. So this way when you render your project, you're going to be able to delineate what's street versus what is grass or what is, earth. And so again, I can also come in here and select this part and change that to another material here. Let me choose, see if I can find a grass. So we've got grass right there. I can add that. And you can start to, it's kind of dark up there on the screen, but you can start to see how you can start to delineate your different parts of your topography surface. Does that make sense? So the last part really, and then I'm going to, I'll give you kind of a quick link, and I've actually given this link to you before. It was on the one of the first workshops that I did. I gave you a bunch of links to other videos. I have one on topography that goes into a lot more detail. If you really want to be very specific about curb cuts and making your road, 6 inches down, and then you usually have like a 6-inch curb, and then you have your grass. And if you want to get that detailed with your model, which obviously will make for a better rendering and a better presentation, you can kind of look at some of the methods I did in there. I don't want to, waste a whole class on that. But the last part that we need to do here is get this to interact with your building. So if I were to actually have a building model, and I'm going to have to generate kind of a box here or something basic. Let's say I've got my building and it's going to be sited right here. And I'll go ahead and let me just make a floor. Again, let me just do something simple, a box. I'll draw some walls. I can go into the level of detail of the curb cuts and all that if you guys really want me to, but I just want to make sure we use our time wisely. You just let me know. I'm going to draw just a quick little box here of walls. Guess I made a pretty big floor plate there. So let's say that that's my, building, and you can see where it's floating above the ground. And actually, most likely, you probably have a building. If you guys are doing an office building, you probably have something down below grade. I would assume like a parking structure or something. So I'm going to put this down negative 12 feet, and then make all that go down with it. So anyway, let's say that's where my model should be, and you can see I've got the kind of the ground level here, or the bottom of the building here is under the grade, or below grade. And so if I were to cut a section through this at this particular moment and look at it, what's going to happen is you're going to end up with your building model with your floor and then all the ground going through your building. So essentially right now it's still acting like this hatch pattern needs to go up to the top of the topography surface, and since those aren't interacting right now or interconnecting with the building, it's basically going to go through your entire drawing. So to sort of cut that off and make it work the way a typical section would look when you're kind of working with topography, so I can go back into level 1, and what you would do is make what's called a building pad. So if you go to massing and site, there's this other option here called building pad. And when you click on that, basically that's going to be, you're essentially tracing the footprint of the building that you want to sort of go below grade or get cut out of. So essentially what you do, in this case I've got a pretty simple box, so I'm just going to trace from here to here. And a couple options that you have are, where is this building pad going to be located? So the building pad right now, if you remember, I kind of moved my floor down -12 feet. Well, I want my building pad to actually be below my floor slab. My floor slab, I think I did a generic, actually I should probably measure it real quick. Excuse me. Won't let me measure. So it's probably like a foot. So what I'm going to do is specify that when the height of my building pad, over here you see your constraints, set to level 1. I'm going to change this to -13 feet. And another thing is you can click on edit type associated with the pad, and that will give you and show you that your pad is 1 foot thickness. And then you could give it a material. So if you wanted to give it like a gravel pattern or something like that, typically slab on grade would be on top of 4-inch compacted gravel. If you're actually doing a real, kind of world project and trying to get a realistic section. So I might type in 4 inches here, and then try to find a material here like gravel or something like that. See if that's even possible. Here we go, gravel. It looks like I don't really have any a graphic pattern that's associated with it, unfortunately, which I can give you guys one if you really want. But anyway, I'd specify, and I picked grass somehow, and I picked gravel. There we go. So right now I don't really have a cut pattern that's associated with it, and I can go into a pattern file that I can actually give you access to and show you how to use that in a minute. But I'll just hit OK and OK and OK out of that. And so what this does now is when I hit the checkbox, it should cut the ground. You can see now how the floor is revealed. It cuts the ground out of whatever was inside of that building pad outline. And now when I look at my section, turning off the CAD file, you can see now I've got my topography and it's cut out, and it looks like how it should when you're actually trying to present your work and your particular drawing. Now it works the opposite way as well. So let's say for some reason your ground or your bottom floor, and so if I were to move this up, let's say I was actually above the first, or above the topography. So let's say my first floor was actually like that, and I was trying to put my building on here. And you can see where obviously I'd have to do some topography work to either regrade this. And I'll go over that in just a second. But the other part about the building pad is it works the other way, where I can click on it, and if I were to, I have to probably tab over this a couple times. Cancel. So I'm going to tab over until it says pad down there at the bottom, and I'm going to bring this up to let's say 4 feet. And so what it will do then is actually build up a mass until it gets up to the, the bottom of the building pad. So again, if I look at a section, you've got that sort of built up there, and then you can figure out what you need to do for the rest of your topography to go around the building. And the way to manipulate topography, the suggested way that I prefer, is to leave the old topography as is, unless you have to, obviously cut it and slice it into multiple pieces to, start deleting parts of it. But what I would do instead of editing the original, because what would happen is if I select this and click, let's see, topography surface. So that's editing the boundary. So you can see I can't actually, I thought I could, get back into, here we go, edit surface. So if I tab over a couple times, I can eventually get this edit surface button. And this is the way I don't recommend, and the reason for it is, when I go back into this, in order for you to manipulate this surface, look at how many points were generated to create this thing, and it'll pop up here in a second. You would have to go in and select all of those points and change its elevation and say, okay, now I want this contour, I'm going to change all those to be 1 foot up or 2 feet up, and you'll spend probably 2 nights selecting all these points just to get it right. So what I recommend is, instead of doing that, is leave this original surface as is and create your own surface on top of it, and then you can actually merge them together. So if I wanted to, let's say, build up this topography, right in here to sort of go up to that level, I might go back over here to my site plan, and I'll go ahead and do a topo surface. And this time, if you remember, I moved my floor up to like 5 feet above level 1, so that's where I'm going to start. Or I might do something a little bit lower, like 4 foot, let's say 10 inches. And I could go around and place some points around the building. Then I could go down, and let's say I'll do the next one, I'll just say at 2 feet. And then maybe I'll do another one here at, I'll just be a little more drastic and say negative 5 feet over here at the corners. So anyway, you would start to build up your own surface, working in this method. And when you're done and you hit the checkbox, I've now got that surface that is now intersecting with the other. And if you just make it where the end of your surface is well below the rest of the topography, then it'll start to show you exactly where the intersections are, between the two topo surfaces. Then when you're done and saying that this is your, sort of your final form, I can actually click this option here called Merge Surfaces, and I can click this one, and then that other one, and it takes away all my subregions, but it would, that didn't work very well at all. So you can see there, it really kind of messed up things. I wonder why that. So a lot of times I like to just keep it the way it is and work with it. Now, one thing that you probably have to do, and if I look at it, you might have to make another building pad that's only associated with that surface in order to cut that one as well, if that makes sense. So that's kind of the gist of working with topography. I'll tell you right now, there's not a whole lot of options. There's also not a whole lot of options in other programs. You're probably familiar with sandbox tools and SketchUp. This is basically the same ability that SketchUp has. You can make your topography surface, and then you make your building pad, which is called a building stamp, and then that's about all you can do, really. And you can kind of push and pull points, but it's kind of the same idea here. One thing to note is when you have these topography contours in this surface, when you place things like trees in your site components, they will actually place right on the surface. So if I pick this this particular tree, it'll actually place on top of the topography surface and not necessarily attached to level 1, but it'll actually be placed on the ground. So you can go ahead and get those to be, located correctly. And remember, from rendering, those aren't how those trees look. When you render them, they look a lot better, if you remember that kind of workshop. If you go to let's see, those links that I've been sending to you, just so you know, the jrodesign.com/Revit, if you go to the archive section, I've been putting all of your videos from all of the workshops over here on the right-hand side, the very first top 4. And so in one of these, you can see here I've got the link from workshop number 1, where I said here's a special link that will take you to a video regarding topography. I don't know if you had a chance to look at it, but you might revisit that. And this is one where I kind of go over an example just like we did now in a little bit more detail, but I get into how to, if you really want to make curb cuts and roads and all that type of stuff for working with the topography tools. There's kind of this little trick that you have to do that's a little bit tedious, but it does work. And it does make for a nice model if you really want to get to that level of detail. And you're really going to notice that when you take your rendering shot, so if you're doing a camera view and you're standing in the street and you happen to be looking at front of your building and you see your curb cut, that's probably where you want to do that kind of level of detail if you're going to be that close to your to that location. And I wouldn't do the curb cut on the back side of the building if you're never going to take a 3D view of it, because that would just be wasting time. So it might be something to do depending on once you set up your camera views and your different views for your renderings to figure out where you need to go into much more detail. Any questions? Does that seem?
I have a question.
Yeah.
So we're starting to draw like sidewalks and ramps, accessibility kind of stuff.
Mm-hmm.
What's the best way to, like, we're gonna have to show the topo lines on like those sidewalks and everything. Is the best way to do that to draw them as separate topo surfaces or ramps, or what do you think?
So the sidewalks and roads and things like that, you're going to want to actually be part of your topography surface.
Okay.
And so the thing there where I just did the subregions and made the roads like that, the reason I did that is because now those roads actually follow the topography surface and all those contours. So same thing with sidewalks. Your sidewalks will probably follow your surface, or you can make your own topography surface. So you'd want to start picking points and make your sidewalk, at different intervals, along your contours, because then it will show, as long as it's a true topography surface. When you look at it in your plan view, or actually even in 3D, you can see it'll generate contours for you on that surface, and those contours are based on, again, on these settings. So again, I could also make this more detailed, make it 6-inch contours, and you can see I got some added contours in there. Now the ramp, that one you're going to have to, because you're actually going to be working with ADA requirements, I would actually use the ramp tool. So I'd go over here to level 1 or whatever floor you're trying to get to, and you can click on architecture and ramp. And then I would say, let's say I am trying to get from, let me pick a point over here. Let's see. Let's say I'm going to start ramping up from this corner, and I'm going to try to get up to that location. Mm-hmm. What I would do is, this is where your spot elevation tool comes in handy. I can click on annotate spot elevation. I can look over here that just so happens that this is pretty much right at 0, but this would be the start of my ramp is at this location. So what I would do is click on architecture ramp, and my base offset would be, in this case, this is probably too exact, but 1 and 1.75 inches or so on, or you could keep it at 0. But obviously, if you were at like 2 feet or 1 foot, I would make my base offset that value, because that's my starting point. And then I'm going to say, where do I want to go to? So the top level of the ramp. So here's level 1 is probably where I want to get up to. So let's just say I need to go to level 2 just for this. Actually, my floor was up 5 feet from level 1. So let me do level 1, top level, and my top offset is at 5 feet. And then here's the width of your ramp, so you can figure out what the requirement is for ADA, or if you just want to be more generous and say, 5 feet or something. I can now draw, and you would draw a ramp by run. So here's the option here, kind of like with the stair tool. Remember when we went over that in kind of brief? You kind of draw here, and it'll allow you to, just like with the stairs, it'll show you, okay, I've got 58 feet left to go in order to get up to this top level. And it already has built-in ADA requirements in it. Notice I can only draw this ramp 30 feet in length. If you look at the code, it says your ramp can't be longer than 30 feet, and it can't rise by more than a certain height. Well, in this ramp program, it's already programmed to have the maximum incline length here is at 30 feet. And then your ramp maximum slope is a 1 to 12. So, the whole ADA thing is actually kind of already programmed in here. And if you're trying to be a little bit less of a slope or whatever, you can change your ramp maximum to, like 1 to 16 or 1 to 20, whatever it is you're trying to get to. But 1 to 12 would be obviously the maximum. And then I would just draw, let me see, I'll draw that. And then I would pick where my next portion of the ramp is going to be, and it'll fill in a landing in between.
Mm-hmm.
And so let me see if I can finish that up. So that might have been the end of the ramp, I'm not sure. Oh, I must have did a boundary by accident. So then when you're done, you can open up the door. I don't know why it's locked. So when you're done, then you have your ramp that's starting out on grade, essentially. Mm-hmm. And this ramp, when it's going up above the ground, and I'm actually going to delete those horrible railings, but you can actually pick that ramp, and so right now it's floating above, and you can figure out how to blend that together, or you could go back here to where it says edit type for the ramp, and you can change the shape from thick or make it go to solid, and that would fill it in all the way to the base.
Wow.
So your sidewalks and your road would be topography surfaces, and then when you get into your ADA requirements for your sloping of surfaces for ramps, I would use the ramp tool.
Where to fill it in with the ramp material?
Yeah, whatever the ramp material happened to be. So if you wanted this to be like a brick wall underneath or something like that, you would actually physically want to draw a brick wall underneath it instead of making this, because otherwise it would turn your ramp walking surface into brick as well, unless that's what you want. But so it won't delineate the sides from the top.
Well, once you have that geometry, you could use that surface to build your wall from, right?
Yeah. Yeah, so you could draw a wall underneath it. So if I were to come back here, let me just do a quick example of I'll just do a brick wall. If I look at this in elevation, this would be the best way to sort of work with that component. Let's see where we're at. So I'm going to isolate that. Use the hide element. Oop. Wanted the other one. Isolate. So it's probably not the best. Let me just do a simple wall.
Sorry, I totally didn't.
No, actually, we were kind of wrapping up. So what you would do here is, if you remember in one of the very first classes when we talked about editing wall profiles, this is where the edit wall profile comes in handy, because this is a ramp. We can't actually attach it to that surface unless it was a floor or a roof or something like that. So because it's a ramp and it doesn't recognize that tool as of right now, we can click Edit Profile, and then you could pick lines, and I would go around and pick kind of the top of that ramp, and then you just need to make sure that you trim, sort of close those together, and then delete that other line. And that would get that wall to be exactly how you want it to align with the bottom of the ramp. This way then you have more control over the materials and how that's going to look.
Could you do that, accomplish the same sort of thing, not a brick, but with a pad under the ramp?
Not necessarily, because the pad is always going to be level.
Uh,
So you would end up, you know, like this building pad over here is only going to go, it's always assuming your floor is level. So the building pad is always going to be kind of, you know, straight at the top. Any other questions or topics? Good?
So this is wrapping up the sort of topo stuff?
Yeah.
Okay.
And I've also recorded this, so it'll be another little link that if those who didn't get opportunity to be in here can view it. And then I've also went back to our first workshop. On the first workshop page, I did put in here a link to kind of a more detailed session on topography if we really want to get into it. But the surface that we built right here, that's actually from that AutoCAD file that you guys have for your class. So you should be in pretty good shape as far as getting your topography in there.
How does the surface come out?
Except for the mound that I have in there, because that's what I added at the end. You know, it's pretty decent. And the one thing that I was kind of displaying and talking about is, you know, when you cut a section through all of this, you know, it gives you your hatch pattern and your cut line and all that kind of stuff associated with topography. So you get some, you know, you have to change the scale of this a little bit, but you get some pretty good idea of how your grade is interacting with the, you know, the side of your building. So I'll go ahead and stop the video, and then I can walk around and help out individuals if you have specific questions, and if not, we'll go from there, I guess.
Yeah, sure. Okay, so I'm gonna, obviously we still need to look at everybody who's in here.
So actually for the hatch patterns, if you're trying to make your own, or to make your own, it's a little bit complicated, and I'll kind of show you here real quick. See if I can find. Yeah, so in workshop number 3, when I gave you guys that zip file to download, in that zip file there was one in here called AutoCAD Patterns for Revit, and it's a .pat file, so it's a pattern file. And when you right-click on this, and I'm going to open it, and you don't have to do this, but this is what hatch patterns look like. So you see all this line-by-line code. It's pretty crazy that they haven't made this a little more easier to make. So the good news is there's this pattern file that I have that I made available to you, and you can use it to bring in you know, pretty close patterns that you want to use. So to work with those, what you would do is under your Manage and your Materials, over here where you've got your Graphics tab associated with your material. So let me, I'll just go to a default for right now. So the surface pattern, this is where I'd want, this is anything that's going to be shown in elevation or section. I could click on where it says none, or if it had another material there, just click on that white space. And then I can go ahead and click on whether I want this to be a drafting pattern or a model pattern. And remember, the difference there is the model pattern is always going to be true to scale. So if the line is supposed to be 8 inches apart, it's always going to show up 8 inches apart relative to full scale, meaning that when you scale your drawing to 3/4 inch or 1 inch, that those lines are still going to be represented at that scale at 8 inches. Whereas a drafting pattern scales based on your scale. So for instance, brick, 2x2 tile, anything that needs to be represented in a true scale needs to be a model pattern. Anything like cross-hatching or earth, you know, the earth cut pattern, you don't really need that as a true scale. So anyway, I might come in here and go to drafting, and I would click on new. And this is where you can make your own pattern. So if you had a pretty simple parallel lines, you know, kind of these, let's say your perforated panel was looks like this, you know, just a crosshatch. You could actually give it, you know, what the dimensions should be, or whether it's 45 degrees or 90. You know, you don't have a whole lot of options there. The other thing would be you can make a custom pattern, And this is where you click on import, and then you're going to browse to wherever that PAT file is. If I go ahead and load that up, here we go. I think I might have given you some other pattern files too. So all these 3 pattern files are what you have available to you. So if I go to AutoCAD pattern files and click open, then down here there's the name associated with each one. And when I here we go. When you start looking, scrolling down with the cursor key, you see the pattern kind of thumbnail version of it. And so you can kind of click through those and find something that you would want. So let me find something real basic. So here you go. Here's kind of a mesh look or something like that. Or here's kind of a honeycomb or kind of a perforated pattern. So I might click on that and hit OK. Click OK again, and then also give it some kind of grayscale. And now that's associated with your particular pattern. So wherever you draw that, that's going to show up in elevation. So you can use those, and then try to get it to represent your perforated pattern is the best idea. And then it's going to taper up.
It's like the last 3 or 4 feet.
Okay. So if I had a ceiling plan and I go to my architecture, I'll just sketch one right here. So you can do a couple things. You could either, so I have this flat one. What I would probably do is draw another ceiling that's going to be representing of the tapered portion. And so I'd go to ceiling, go to sketch here. Let's say this is going to be my taper right there. While you're in this sketch mode, there's this little slope arrow. So you can actually go from one point to the other. And then it says height offset at tail and then at the head. So obviously where the arrowhead is, that's the head portion. And so if I wanted that to, from my tail would be 0. And this is going to be relative to the level of where you put your ceiling height at. So if I wanted it to taper up let's say 3 feet higher, I would do an offset of 3 feet. And then if I look at, obviously the hatch pattern there would have to be fixed. But if I look at this in section,
Okay, great.
so wherever this initial height is, height offset from level, that'll be the base, and then you can taper that up. The other method would be if you had more of an intricate shape, because obviously this is only going to do just a one angle. But let's say you had some kind of form shape to it, I would actually make a profile that looks like that, and then do like a sweep,
Okay.
kind of like a model in place. Do you know how to do that?
Yeah, I think this actually works though.
Okay.
That's a lot simpler than I thought it was.
Yeah.
It's just like doing a ramp.
And you can actually do it, a little more complex too. So I could, if I go back into this, let's say it doesn't, let's say it actually slopes from here to there, like across the corner.
Yeah.
You can actually do that as well, and it'll make, a pretty complex form there. So if I look at that in 3D, and there's my hatch pattern. It's kind of hard to tell what it's doing there. I guess it still did it pretty constant though.
Yeah.
I thought it would warp it a little bit more. When I do it with roofs, it seems like it warps it, or actually, slopes it a lot better. So anyway, that would be the probably the best way to do it.
I think that'll work.
And again, like I said, if it's more complex, I can help you with a profile and then how to sweep it,
Okay.
because you can come up with all kinds of shapes that way.
Okay. Thank you.